Hey everyone, this is Mr. Combs. I wanted to go ahead and create this video because I know that I said that we were going to finish up truth values and argument, truth tables, truth values, truth tables, arguments next time in class. So not today on Tuesday, but next Tuesday when we meet again. But I realized that this class period coming up, a test is due, right? I think a test is due. Um, so you'll need to be able to work with arguments and determine if arguments are valid on the test. So what I thought I'd do is just make this video for you. So we will not be talking about arguments in class next time, but this video will be what we would have said. I know it's not as good as being in class because you can't stop me and ask questions, but I think that we'll be okay. Um, so let's just take a look at this. Now, I think that we got to this point, excuse me, where we were talking about not the biconditional, but the conditional. We'll talk about the biconditional in just a minute. So before this, we had talked about not, and remember that not has the opposite truth value of the original statement. So if we have P, and that's true, then not P is false. We talked about and remember that if two statements have an and between them, the truth value of that is T, as long as both of the statements are true. If either of the statements or both are false, then the truth value is false. And then we also talked about or, and that's true as long as either of the statements are true. They don't have to both be true for or to be true. So next what we want to do is introduce truth values for the conditional statement. Now remember, a conditional statement uses the symbol of an arrow, and what that arrow stands for is if then. So this means if P then Q. So if you're the statement that goes along with if, or the first statement is called the hypotheses, excuse me, or hypothesis. Hypotheses is plural. And the second statement after the then is the conclusion. So there is only one way a conditional statement can be false, and that is if there is a true hypothesis and a false conclusion. So let's see if this makes sense, and I think you'll find it does. Consider the following situation. So your boss says to you, if you work on Sunday, that's P, you will get a $100 bonus, and that's Q. You get a $100 bonus. So let's think about this. If P is true, so if we have a true statement, then we have a true statement. So if P is true and Q is true, then you came to work on Sunday and you got the bonus. Your boss told the truth. And I realize that here I put Saturday now, so let's just change that to Sunday. Sorry about that. One of these days I'm going to give you a document that has no mistakes on it, but don't hold your breath, is what I'd say. So if we have this situation, if a true statement, then a true statement, then we know that that is true. So that truth value is T. If P is not true, so if we have a false statement for P, but we still end up with a true statement for Q, then that's also true. Because let's say that you didn't come to work on Sunday, but you still got a bonus. Well, your boss didn't say that you wouldn't get a bonus if you didn't work. Your boss just said that you would get a bonus if you worked. If you work on Sunday, you will get a bonus. So he still told the truth. You still got the bonus. He or she, I guess. If P is not true, so if you have a false statement, And if that leads to a false statement, so if you did not come to work on Sunday and you did not get a bonus, well, your boss still told the truth, because your boss said that if you came to work on Sunday, you would get a bonus. You didn't come to work, so you didn't get a bonus, and your boss didn't lie, so that's still true. However, what would happen if you came to work on Sunday, and then when you looked at your paycheck, you realized the bonus wasn't there? So that is a true statement that leads to a false statement. This is the only time that you can get a false statement, when the hypothesis is true and the conclusion is false. All right? So if P then Q is false only when P is true and Q is false. So let's construct a truth table for this conditional statement that deals with if then. All right, so I know that I need, I'm sorry, I don't know why I'm yawning. So I know I need a P, and I know I need a Q. I know I need a not P. I need a not Q. I need a not P or Q. I need a not P and not Q. And then I need the conditional, which actually I drew that wrong. I need the conditional statement, which I'm just going to say is an arrow. So that's actually this statement right here. I don't want to have to rewrite that. Okay? So I have 4 situations that can happen. And I'm going to do this in a different color. Let's try purple. I have both P and Q can be true. I have P can be true and Q can be false. I have P can be false and Q can be true. And then I have both statements false. All right, so let's see if we can create a truth table for this statement. All right, so not P is the opposite of whatever P is. So if P is T, not P is F. So false, false, true, true. And just to make sure that we know that that's false, there we go. So false, false, true, true. All right, now not Q will be the opposite of Q. So true, false. So Q is true, false, true, false. So not Q will be false, true, false, true. So false, true, false, true. All right. Now, not P or Q, remember that's or, it can only be false when both are false. So let's see, we're looking at not P or Q. So true, false, that's true. False, false, that's false. True, true, that's true. And false, true, that's also true. Okay, now I'm looking at not P and not Q. Sorry, so not P and not Q. So remember, those are to be, in order for this to be true, both of these statements have to be true. So false and false will give me a false statement. False and true will give me a false statement. True and false will give me a false statement. And true will give me a true statement. Now, the if-then statement is next. And so what we're going to do is we're going to look at this statement first and then this statement. So remember, if the first statement is true, the second statement is false. That's the only time this can be false. So here we have a true false, so that means that's false. Here we have a false false, that means that's true. Remember, false false is a true statement. True and then false, that's false again. And then true and true, that's true. So that's the truth table for this statement right here. I don't know why I'm yawning. Before I got on this video, I wasn't yawning at all. I guess it's just the power of being on video. All right. We also have something called the biconditional. And the biconditional says that two statements mean the same thing. And it uses a double arrow. So what P double arrow Q means is P, if P then Q, and if Q then P. And what the biconditional statement is stands for if and only if, sometimes abbreviated IFF. So IFF is if and only if. So the biconditional statement is true when both P and Q are true. I'm sorry, no. Well, that's true. The biconditional statement is true when both P and Q have the same truth value. So that if both P and Q are true, then it's true, and if both P and Q are false, then it's true. So T double arrow T, that's a true statement, and F double arrow F, that's also a true statement. Okay? So let's construct a truth table here, and I'm going to get rid of this so I can use this space. But let's construct a truth table for this statement right here. So I'm going to get rid of that. And I know that I need a P I know that I need a Q I know that I need a not Q. I know that I need a P or Q. Then I need a not P or Q. And then I know that I need a not Q and P. And then finally I need that biconditional, and I'm just going to represent that as a double arrow. Well, now we're ready. So I could have a true, true. I can have a true, false. I can have a false, true. Or I can have a false and a false statement. All right. So not Q is just going to be the opposite of Q. So that's going to be false, true, false, true. P or Q will be true if either P or Q is true. So true, true will give me true. True, false will give me true. False, true will give me true. And false, false, that's the only one that gives me false. Now, the opposite of that will be false, 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 true. And now I have not Q and P. So not Q and P. All right. So remember, and both have to be true for the statement to be true. So true, false, that means that's going to be a false statement. True, true, that means that's going to be a true statement. False, false, that's going to be a false statement because they both have to be true for not Q and P to be true. False, false. And then false, true, that's also going to be false. All right. Now, for the biconditional statement, the last statement that we have, if these two are the same value, then it's going to be true. So false, false, that's the same value, so that statement is true. False, true, well, that's just false. False, false, that's true. And true, false is false. All right, cool. So let's look at an example. You may have some problems like this in your homework. This is an example we're not going to use a truth table for. We're just going to sort of answer it. It says, the Chic Boutique has the following policy. If you return clothing within 30 days with the original label on it, so this is like saying if P and Q, then you will be given a full refund. You will be given a full refund is an R. So what we're saying here is if P and Q, then R. All right, so what we have here is Sandra returned her suit with its original labels. So let's see. So if you return clothing within 30 days, that's P. The original labels on it, that's Q. You'll be giving a refund. So Sandra returned her suit with its original labels. So Sandra actually, let me go ahead and put this arrow there. So what I'm saying is P and Q. If P and Q, then R. So Sandra returned her suit with the original labels on it, but I don't mean to write that there. Let me get rid of that. So Sandra returned her suit with the original labels on it, so she had Q, but she was not given a refund. So we have Sandra is Q and not R. What can we conclude from this information? Well, what is missing here? Sandra returned her suit with its original labels on it. What was missing? What part is missing? I have Q here, but I don't have P, so P is missing. right? So if you return clothing within 30 days, that's P. So what can we assume, or what can we conclude from this information? Well, she returned it with the original label, but she was not given a refund. So that means that she did not have, or it wasn't returned within 30 days. So that means not P. That's what we can conclude, is that it wasn't returned within 30 days. So not. And excuse my big writing, I'm trying to write with a mouse. There you go. All right, so let's talk about what an argument is. This is actually an argument. An argument is a series of statements called premises, or a premises, followed, which is one, followed by a statement called the conclusion. An argument is valid if, whenever all premises are true, then the conclusion must also be true. So if you have a truth table, that's when you have a tautology. And that's a truth table that always is true. Every last column is T. Okay? So arguments take the following form. You have premise 1, premise 2, and the conclusion. So this is an argument that we had up here. So the argument is, if you return your clothing within 30 days with the original labels on it, then you'll be giving a refund. Sandra returned her suit with the original label, but was not given a refund. So the conclusion is that she didn't return them within 30 days. So we could create a truth table using this argument and see if, and we could, fill out the truth table and see if we get T in every space in the last column. So to verify an argument, we're going to do just that. We're going to write the argument symbolically. We're going to join the premises together with and. We're going to form a conditional statement using the conjunction as the hypothesis and the conclusion of the argument as the conclusion of the conditional. We're going to form a truth table. And if you have a tautology, the argument is valid. So let's look at a couple of these. So let's consider the following situation. It says, if you have a value card, you get a discount at Food City. You did not get a discount at Food City. Therefore, I think you don't have a value card. Let's see if that's true, okay? So what I'm going to do is I'm going to write this symbolically. So if you have a value card, let's let that be the statement P. So if you have a value card, you get a discount. That's going to be Q. All right? So I'm going to rewrite this as P arrow Q. So if P, then Q. Okay? But guess what? You did not get a discount. So we have not Q. And we think that therefore you do not have a value card. So we think that this means not P. So we can rewrite this by saying that if these two things are true, then this must be true if the argument is valid. So I'm going to say that I have P arrow Q and not Q. So I'm going to say if that is the case, then not P. And what we're going to do is we're going to find a truth table for this statement. All right. So I know that I need a P and a Q. I know that I need a not P and not Q. I know that I need an if P then Q. And I know that I need an if P then Q and a not Q. And then I need the last conditional statement, which I'm just going to let an arrow represent that so I don't have to write all that out. So that's going to be this statement right here. Okay? So let me fill out the truth table. So the only thing I have to worry about is situation where they're both P and Q are true. P can be true, Q can be false. P can be false, Q can be true, or they both can be false. Okay, so not P is going to be the opposite of P. So true, true, false, false. So I have false, false, true, true. And not Q is going to be the opposite of Q. So true, false means I have false, true, false, true. I'm going to go ahead and draw these horizontal lines to help me keep my rows straight. All right. Okay, now I need if P then Q. Now remember, if the hypothesis is true, the conclusion must also be true. So true, true is true. True, false, that's false. False, true, that's true. And false, false, that's also true. Okay, now what I need is this column, if P then Q, and not Q. So I'm going to look at this column and this column. If they, remember, and means that in order to be true, they both have to be true. So I'm going to say false and true means false. False and true means false. False and true means false. And true means true. So false, 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 true. Now what I'm going to do is I'm going to look at if this column, then not P. So that means that I need to look at this column and I'm going to compare it with this column. So if this is false and this is true, then it's false. Okay? So false, false, that means it's true. False, false, that means it's true. False, true, remember we said that was fine. That's true. And true, true is true. So I've got T for every single row in the last column. That means that this argument is valid. I have a tautology, excuse me. So this argument is valid. So valid. Let's look at another one. So this one says that Jane wants to improve her cardiovascular fitness. Okay, so let's take a look here. If Jane wants to improve her cardiovascular fitness, let's call that P, then she should take up cross-country skiing. So if she takes up cross-country skiing, that's Q. Jane takes up cross-country skiing. Oh, excuse me. So that's Q. Therefore, she wants to improve her cardiovascular fitness. So P. So what this is saying is, if P, then Q, and then we know that Q is something that she wants, or she takes up cross-country skiing. So we know that Q happens, and we're going to conclude that then P must be true as well. So we can rewrite this as, if P, then Q, and Q So remember, to come up with our statement, we take these two things together. We take these things and put an and in between them. And then we say, if this is true, then this must be true. So I'm going to say, then P must be true. So let's see. Go ahead and put parentheses around that. So what we need to do is we need to find a value for P, a value for Q. Then we need P arrow Q, so if P then Q. Then let's see, we have if P then Q and Q. And then the last one we have is the conditional statement. And I'm just going to draw that arrow there so we don't have to rewrite all of that in this last column. So let's see. The only things I can have, the only situations I can have are true, 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 false, false, true, or true, true. No, we've already had, I'm sorry, we've already had true, true, false, true, or false, false. Just a second, let me fix this. Sorry, I don't know what my problem is. It's probably that it's after lunch and I'm sleepy. Maybe. So that's really false, false. All right. So this one isn't so bad. If P then Q, that means that as long as P is not true and Q false, then I'm fine in this case, right? So let's see. P is true, Q is true. That means if P then Q is true. True false, that's bad news, so that's false. False true, that's just fine. And false false, that's just fine as well. Now, if P then Q and Q, so we need both of these to be true in order for our statement to be true. So true and true is true. Good. False and false, that's false. True and true, that's true. And true and false, that's false. Remember, for and, they have to both be true in order for the statement to be true. Now what I need is the conditional. So what I'm saying is, if I have this statement, then that should lead to this statement. So true, true, that's great, true. False, true. If a false statement, if I have a false statement, then a true statement, that's the only time that's false, so that's false. Oh no, I'm sorry, that's not false, is it? Yeah, it is. No, it's not. I'm sorry, I'm confused. I'm confusing myself here. Let's start over with this one here. Okay, so I have a true statement. If T, then T, that means T. True. If false, then true, if false, then true, that's also true, right? If true, then false, that's the one that's false. And if false, then false, that's also true. So I made a mistake on mine. True, and then false. But it doesn't matter, because in order for this to be a valid argument, then this would all have to be true. So it's not a valid argument. So I would say that this is not valid. And that makes sense if you think about it, because think about this. If Jane wants to improve her cardiovascular fitness, then she should take up cross-country skiing. And then we hear later that Jane takes up cross-country skiing. That doesn't necessarily mean that she wants to improve her cardiovascular fitness. She could be taking up cross-country skiing for a variety of reasons. Maybe it's to meet new people. Maybe it's because she really likes the snow. It doesn't have to be that she wants to improve her cardiovascular fitness. So this is not necessarily a true statement. In fact, in some situations it's true. In some situations, one situation, it's false. But this is not valid all the time. Like, in fact, this situation is valid all the time. If you're guaranteed a discount if you have a value card, the only reason why you didn't get a discount at Food City must be because you don't have a value card. So that is a valid argument there. So I hope this helps with arguments. And like I said, if you have any questions, just give me a call, come and see me, send me an email, and I will see you all next Tuesday.